All right, so we are going to talk about multiplicative and additive relationships and where we see those on tables, in graphs, and in equations. Now, the words multiplicative and additive are not new words for us. We talk about multiplicative and additive when we sing our order of operations song. Remember, it's fun to do the GEMA. So the M stands for multiplicative. And when we recap our order of operations, multiplicative is multiplying and dividing, those two operations. Additive is adding and subtracting. So now we're going to look at the type of relationships that we can create with those specific operations and the characteristics that we look out for. So if I'm talking about a multiplicative relationship and I'm on a table, let's pause here for a second. 54. Okay, so when I'm looking at a multiplicative table, here's the one thing that I want to look for. The table may, and it's important that we include that word may contain the point 0, 0. And we know the point 0, 0 is also called the origin. So the reason it says that it may contain the point is because they're going to try and trick you by leaving 0, 0 off of the table. So it may contain the point 0, 0. But if it's an additive relationship, the table is never, ever, ever going to show the point 0, 0. So multiplicative, it may have the origin. Additive, it will never, ever have the origin. So on a graph, it's kind of the same concept. On a multiplicative graph, the line will pass through the origin, which again is that point 0, 0. But on an additive graph, the line will not pass through the origin. Again, point 0, 0. So let's take a look before we move on to the equation at just these two things. I'm going to start with a table. I'm going to zoom out just a little bit so I got some room. All right, so let's start with our multiplicative relationship. So our scenario says, at Kelly's furniture store, an employee's salary is determined by the amount of furniture that he or she sells. The salary is 1/5 of the employee's total amount of sales. So again, when we see that fraction next to the word of, that tells me that I am multiplying. So let's say someone sells $200 worth of furniture. Their salary is going to be 1/5 of that $200. So to figure out their salary, our process would be 200 times 1/5. So if I do 200 times 1/5, I got some room over here. So we know when we multiply with fractions, we need a top times the top and a bottom times the bottom. So I need to put 200 over 1. I'm actually going to do my Smith Super Secret math hack here, and I'm going to simplify. So I know that 5 will go into 240 times, and 5 divided by 5 is 1. So if that person sells $200 worth of furniture, they're getting $40 for their salary. I can do the same thing. Let's say they sell $450 worth of furniture. So that's 450 times 1/5. So let's set up our problem. 450, 1/5. I'm going to do my Smith Super Secret math hack. So 5 will go into 450 90 times. So that employee is going to earn $90 for their salary. If it's 750, my process is going to be 750 times 1/5. Oh, I did not leave myself very much room. Okay, so my Smith Super Secret math hack tells me that it will go into it will go into 750, let's see, 150 times. So that employee is going to make $150 on their salary. And our last one, 900, I'm going to do over here so I have some room. So 900. So that'll go in 180 times. So the employee is going to earn $180. Okay, so on our table, remember what we were looking for is the table may contain the point 0, 0. But when I look at my table, I don't have an x of 0 or a y of 0 ever. So here's what I need to think about. If I am an employee and I sell $0 worth of furniture, are they going to pay me a salary? Absolutely not. If I don't do any work, if I don't make any money for them, they're going to pay me nothing. I get $0. So it wasn't on our table, but we figured out that 0.00 really could be on the table. They just chose not to put it on there. So again, that's why we say it may contain the 0.00 if it's multiplicative. Now, if it's additive, this situation says Drake is 5 years younger than his brother Ryan. So in this situation, Drake's age depends on Ryan's age. So Drake's age is Y, and it depends on how old Ryan is. So Ryan's the older brother here. Says that Drake is 5 years younger than Ryan. So if Ryan is 6, Drake is 5 years younger than that. So that means Drake is 1. If Ryan is 8 years old, Drake is 5 years younger. So 8 minus 5, that means Drake is 3. If Ryan is 11, Drake is 5 years younger. So Drake would be 6. And if Ryan is 14, Drake is 5 years younger. So Drake is 9 years old. So now let's think about if Ryan is 0, which means he's just been born, is Drake even in existence? He's not. I can't do that 0 minus 5 because that would mean that Drake is negative 5 years old, and that's not possible. You can't be negative 5 years old. So in this instance, the 0.00, it does not make sense to have it on our graph. They can't both be 0 at the same time if Drake is younger than Ryan. So again, that's why our additive table will never ever have the 0.00. Okay, so now let's talk about our additive and our multiplicative graphs. Okay, so on our graphs, it says the graph looks like a line with points that may or may not be connected. So we're going to use this information that we have up here to be able to plot our points. So we know that the furniture sales is our x-axis. The salary earned is the y-axis. So the first point that I need to plot is x is 200, y is 40. So everything's positive here, so we're only dealing in the first quadrant. So remember, I always start at 0. So my x is 200, y is 40. So I'm going to put a dot there. Next one, x is 450, y is 90. So x is 450, y is 90. 750, 150. So 750, 150. And our last one, if x is 900, then y is 180. So what we have to think about here is on this graph, on this example, does it make sense to connect the line, or excuse me, to connect the dots with a line? So if we connect the dots with a line, that means that any point on that line makes sense for our situation. So if I connect the dots here, what I'm saying is I don't have to just sell $200 worth of furniture. I could maybe sell $300 worth of furniture, or I could sell $510 worth of furniture. I could sell $0 worth of furniture. So in this instance, it does make sense to connect our line because you don't have to only sell specific amounts of money. You could sell $600.12 worth of furniture, and by doing that, you could still figure out what your salary would be. So again, if I sell $0 worth of furniture, I'm going to get $0. So our graph here does pass through the origin 0, 0. That line is connecting down there at 0, 0. But our additive relationship, again, this is our example of Drake is 5 years younger than Ryan. We need to plot these points on our graph. So Ryan's age is our x, Drake's age is our y. So if Ryan is 6, we said Drake was 1. If Ryan is 8, then Drake was 3. If Ryan is 11, Drake is 6. So 11, 6. And if if Ryan, goodness gracious, if Ryan is 14, then Drake is 9. So if I were to connect the dots on this one, that would be saying that when Ryan is 5, Drake is 0, which is totally true. That is fine. But that line is not going to go through the origin. So I can connect my dots on this one, right? Because you're not always a specific age. Like Ryan is not just 6, 8, 11, 14. He could be 6.5 or he could be 7. And we could still figure out how old the Drake is. But when I connect those lines right here, it's not passing through the origin. It's hitting our x-axis at 5, 0. So additive relationships will never pass through the origin. And then the last one, let's talk about what our equations look like. So if it is a multiplicative equation, just kind of a general equation that represents a multiplicative would be y equals mx. So I have two different variables there. X is our x coordinate, our x-axis. So y is our y coordinate, our y-axis. But that letter m represents what we call the coefficient. So we know that coefficients are whatever I am multiplying the variable by. So that's kind of the standard variable that we use for our coefficient is the letter m. So on our additive equation, we're not going to have an m. There's no coefficient because we're not multiplying. But on an additive, our general equation could look like y equals x plus or minus b. So again, I'm adding or subtracting something to our variable. Now we know the letter b represents something called the constant. So again, that's what I'm adding or subtracting to the variable. So let's go back to our original examples here. So I got to kind of zoom a little bit. So what our problem says down here is we're trying to create a equation for this example here. So when I go look back up at my chart, it looks like my process is I'm taking whatever my x value is, I'm multiplying it by 1/5, and that is creating our salary. So when I write an equation, I always want to typically start with the output equals. So that would be y equals. And then I'm taking x and I'm multiplying it by 1/5. But when I write that, I have to put the coefficient first. So it's not going to be x times 1/5. It's going to be written as 1/5 x. So to put this in the words, the value of y is 1/5 the value of x. So if I write my additive equation, so again, we have our same sentence. The value of y is blank the value of x. I'm going to go back up to my table here. So it looks like what I'm doing is I'm taking my x value and I'm subtracting 5 from it to get my y value. So the equation that I could write is y equals, I'm taking x and I'm subtracting 5 from it. So to put it into words, the value of y is 5 less than the value of x. So yeah, just the big things here to recap all of this is when I'm looking at a table, I know it's multiplicative if the table may contain the origin. So that's why we always just have to make sure, does the point 0, 0 make sense on our table? If it's additive, you'll never ever see it on there. If it's a graph, a multiplicative is going to touch the origin. The additive, it's never going to touch the origin. If it's a multiplicative equation, we're going to have a coefficient. If it's additive, it's going to have a constant.